I'm Anna Shcherbacheva. I work for Terasolid developing AI tools, and we have many more. So we have a conventional tools I'm going to present today. Change detection, it's aimed for aerial LiDAR data, and it's been a great application for topographic 3D changes that you can see different landscape modifications happening over a few years. And in our software, in TeraScan, one of the products that Terasolid delivers, we have specifically this module integrated for users to process their LiDAR data. And it's been implemented by our CTO, Arto Soinen, and I will gonna walk you through. So the change detection tool, it takes as input 2 point clouds scanned by LiDAR, preferably there should be airborne. And in this case, at the right-hand side, you can see an area scanned with aerial LiDAR. In Finland, it's a city area, and it's colored by change. The data set is open source. That's been created in year 2017, and the second scanning operation happened in 2021. So as inputs, we have to have 2 point clouds, and the point clouds are they are processed, the distance is computed between the reference point cloud and the active point cloud, which is captured later. So the tool can aid you to see the buildings that are constructed within the few years between the scanning operations. You can also see the trees newly planted in the landscape, like park trees and the small forest sites, and the harvested trees or fallen trees, or trees newly planted. You can also see demolished buildings and new buildings constructed, and extensions to the buildings that has been constructed during a few years in between the scanning operations. And you can monitor tree growth in addition. So the foundation of the change detection tool is the distance attribute. It's existing in the project. You can specify the distance attribute. It has distance type, and it computes the distance between the reference point cloud and the active point cloud. And that distance can be visualized in the tools, and you can see in red and the color and the right-hand side, you can see the spots which are subject to changes. And the gray area means that there was no changes so far in between the scanning operations. In this picture, at the left-hand side, upper image, you can see the change detection attribute. It's colorful and helps to highlight the areas that were subject to changes. Especially, you can see the red color on the building roofs. And these building roofs highlighted in red, they've been modified by construction, so those buildings are new. And then the right-hand side building, it has some of the extensions built during these few years. At the right-hand side of the slide, you can see the color, the trees and buildings and ground colored by RGB color. So it helps to visualize the structure of the buildings and the structure of the landscape and the infrastructure of the city. And on the image at the left-hand side below, we can see 2 point clouds. So you can visualize reference point cloud that has been captured the first, so the old one, the reference in red and the new one in white color. So in here you can see specifically that two trees on the image, the red trees close to their building roof, they were harvested or they were chopped out. So the changes happen. We can see them interactively in point clouds, which is quite easy to visually assess, and for users convenient to be inspecting visually what's going in the landscape and city infrastructure. The tool, it helps to also visualize the point clouds. You can, for instance, use our display mode in TeraScan. There is a display mode tool where you can choose the attributes for coloring point clouds. In this case, we color by distance. Instead of distance, there could have been RGB color, or there could have been a group color, etc., intensity measured by scanner. But for the purpose of the current application, you are recommended to use the distance attribute, which is preliminary computed before making it visual. This is about producing the rasterized image. Out of the change detection of which is calculated for the old point clouds versus the new, or it can be calculated for new point cloud versus the old, so depending on the application. For example, if you are searching for trees chopped, you should be detecting changes from active new point cloud to the reference old previously captured point cloud. And in the case of the buildings demolished, same. In case of the buildings constructed, is vice versa. So after you have computed the change detection attributes, you can produce GeoTIFF raster image, where the color indicates the height of the objects above the ground. Occlusion option, if you select the occlusion option in the tools, helps to visualize and to make the raster more sharp and contrast. So it improves the contrast for better visual assessment. And you have to have few things. You have to have ground surface classified in order to make a raster, and you have to calculate height above ground before you save the GeoTIFF image. So in case you have your large area scans, there multiple instances of TeraBatch on top of TeraScan can improve the speed performance. So for speedier processing, you are highly recommended to be using TeraBatch on top of our tools. Additional tool which relates to the previous tool that you can track, for instance, the environmental changes, how green is the city currently nowadays, and in the future for your home city, for the municipality you come from, you can capture a LiDAR data, and then you can compare to the old scan, and you can prove that the city you live starts being greener and more trees are planted in few years, and then you can observe that the green area extends in German cities. We recently had a customer of Terasolid who comes from Poland, from Krakow, and there was lots of effort taken to make the city green. And then he made, via the tools we offer, he made change detection and displayed that the city started being more green, and it has better life conditions for people and improved environmental situation. So the tool we offer, it measures the coverage. It can measure the coverage for different arbitrary class. Not necessarily it has to be vegetation. It could have been, for instance, the buildings as well, or it could have been some water area coverage of basically any type of objects and structures that exist in the city infrastructure or a suburban area. So it measures the coverage, the percentage of the polygon area which is covered by a class of interest that you select. For instance, this is for vegetation. For tree, this kind of example. So it calculates this fraction of area covered by the vegetation, and the user can specify the size of the pixel. Once you specify the size of the pixel, calculation pixel will be computed, and there will be the calculation depending on the pixel size that you specify. So you can use different types of inputs. There could be blocks, map sheets, or polygon areas, and be aware that the pixel size, this option, it impacts, and it makes a big difference, or it might have a slighter less difference on the outputs, the percentage of polygon covered by vegetation. But also the density of point cloud matters slightly. The larger point density gives slightly larger coverage percentage for the same pixel size. So this tool can be supplementary to change detection. And thank you for your attention.